So what is a perfect body? It's a body which will absorb all the radiation, absorbs completely all the radiation incident on it. Finish over. No reflection, nothing will be there. It absorbs completely all the radiation incident on it. So no question of reflection. Okay, let's take a since black body doesn't mean that perfect black body means the body will be in black in color. I think please do come out. So not like the color of the body because of that. No, because of the spectrum what pen we are calling it is a black body. Still to make students to imagine I'm giving a black color. Okay, this is what we have, a perfect black body. I'll write PBB. Then we have ordinary body. Okay, let's study the radiation phenomena of these two bodies here. Just like a story, initially we'll start it. So later part will end up with the formulas, and based on that formulas, we have to work out numericals. That's what our thing will be. There's an ordinary body. Ordinary body means I'm indicating here, no need to. What do you mean by ordinary body? The objects around us. The objects around us. Sir, what are objects around us? Open your eyes. What all you see in your room, all that objects around us. Okay, we'll discuss the radiation phenomena of all these two. So initially, both are at surrounding temperature, say like a 20 degrees Celsius. Both are at 70 degrees Celsius, or say like a 80 degrees Celsius. Temperature of both is 80 degrees Celsius. What actually happens here? Both will cool down, no? Both will cool down. And finally, what will happen? They'll attain the equilibrium. At equilibrium, we have to again discuss the phenomena. Okay, this is again at equilibrium. At equilibrium, finally, this will be temperature of this. Let me write on the body itself. Thermal equilibrium is attained. So what's happening to this? This is warm. This is cooling down. No? The both ordinary body is also cooling down. How come? Let's explain the radiation. So what is a perfect black body? It absorbs completely all the radiation incident on it. And what about ordinary body? Need not. A part it will reflect, a part it will absorb. So any difference in this particular thing? The emission spectrum, how it will be? Both will in fact cool down. So let's come for this one. So what actually happens here is it will emit five lines. I'm showing the emission, and the same time what happened, it will absorb. So power emitted is equal to power absorbed. Okay, find this one. So how many lines? How many lines are incident? Green colors are the absorption, and red color lines are being emitted. This is absorbed. This is the emission. What happens with the ordinary body? Ordinary body, what will happen on it? Some power will be incident. Okay, fine. This is. Then what it will do? In that, what will happen? It will reflect. It will not absorb all. So then what happens actually, how many lines it is absorbing? 3 lines is what absorbing. So 3 lines it will emit, for your understanding purpose. So tell me like who is good absorber? All the radiation that 10 joules per second is incident. As the perfect black body will absorb all the 10 joules. Then for temperature to be constant, what happen? It will emit all the 10 joules per second. So therefore, this perfect black body, what will happen? What all radiation is in it is absorbing all and it's emitting all. What about the ordinary body? 10 joules per second is incident. What it does? 6 joules it will absorb. Remaining 4 joules it will reflect. For the temperature to remain constant, what it will do? How much 6 joules it has absorbed, that much it will incident. But how much incident? The incident was 10 joules. In that, it will absorb only 6 joules. Remaining 4 joules will reflect. Okay, let me write in terms of data. Incident power, 10 joules per second. Absorbed power, 10 joules per second. Emitted power, 10 joules per second. Is it okay? This one, incident power here, 10 joules per second. Then how much it will absorb? Let's say 6 joules per second. For temperature to remain same, what it do? 6 joules per second, it will emit. Okay, in this way, the incident power, you can say like, what do you mean by this? How you define the absorptive power? Absorbed energy to incident energy. So what is absorbed and what is incident energy? 10 joules. What is absorbed energy? 10. So what is the ratio of what is the absorptive power for the perfect black body? Shall we put 1? Absorptive power. I think I'll, yeah, PA will write it. So what is the absorptive power? I think yeah, we'll take same symbol. So what is absorptive power for perfect black body? Shall we say 1 for PBB? What about here for ordinary bodies? 10 joules is incident of a 6 joules, 6 by 10. How much you'll get it? 3 by 5. It is less, no? So for ordinary bodies, what is absorptive power? Will be less than 1. Okay, slowly now we have brought in some set of formulas to study the radiation phenomena. So what is absorptive power for a perfect black body? It will be equal to 1. And for ordinary bodies, it will be less than 1. Okay, I agree this. So how the, in thermal equilibrium, how do we can explain? So like this, what happened? We can put it. So what is this green color one? So this particular, these are in, so I'll give these arrows what we are using, no? Now what is this? This will be incident power. And what about red color? Emitted power, and this is reflected power. What all that incident power is being totally absorbed. So therefore I'm writing PA. For ordinary, for perfect black body, PA equal to PI. For ordinary bodies, what happen? The PA will be less than PI. At least able to analyze this one. Like this, what happen? We can explain the equilibrium phenomena of ordinary body. Tell me like who is good absorber? Ordinary body or perfect black body? Perfect black body. Who is a good emitter? Again, the perfect black body. So shall we put it one theorem? Good emitters are good radiators. Okay, now let's come for this one. So what about the perfect black body? It will emit more than the ordinary body. If you look at this, it will emit more than ordinary body. Even when it is cooling down also, it will give out more emission. So here it is cooling down. So if I go and check it now, And in terms, it will be emitting. I'll show only few because for it to cool down weapon, it should emit more than it will absorb. Then only it will cool down. Okay, what about the ordinary body? So for this, though it is same temperature 80, the emitted power will be less. Then here I'll show only two lines. Okay, getting this one now. So who is good emitter? The perfect black body. Who is a good absorber? The perfect black body. So therefore, what we can put it here now. So here perfect black body is PB is cooling down. Ordinary bodies both are in equilibrium. Both perfect black body and our body in equilibrium. So we can explain everything. So when I compare all this, what I say that good emitters, good absorbers. There's one more very important statement. Good emitters are good absorbers. So how to construct perfect black body? Next question comes. So like where do I get perfect black body? So for that, what I do is like I'll take a sphere, a shell, conducting shell made up of iron. Thin iron shell. Okay, let the radiation be incident. Okay, inside I should give, yeah. Inside what happen? I'll give a lamp black coating. All of you lamp black. What do you mean by lamp black? I think when oil lit lamp or candle. Okay, that one, that's what we can call like a carbon deposit. No, soot it is called as SOOT. Am I right? Okay, now since we have got LPG flame, so hardly carbon deposit will be there. But if you are cooking with using wood or any other thing, no, the carbon deposit will be there. No, if you go for any this one noodles, no, fried noodles, what all you eat, no, chats there. Still, what happened? There, what happened on that kadai, what you can call that basin. So black color carbon will be deposited. No, that is nothing but a lamp black. It is called as carbon soot. It is that one. So such a lamp black, what happened? I'll take it. I will give coating inside it. Lamp black is what you can say 95% black body, not perfect black body, 95%. Here we are going for construction of perfect black body. Okay, this is what is this? This is a lamp black. And what is a lamp black? Carbon layer. Now I'll make the radiation to incident on it. Okay, let the radiation fall on it. I just now what I said, the electromagnetic radiation will obey laws of reflection. Let me make some small edge here. Now this radiation, so here say like a 10 joules is incident. In that, suppose 100 joules is incident. So what will happen? The lamp black 95 joules it will absorb. The remaining 5 joules it will reflect. Then again 5 joules is incident. In that 95% will be absorbed. 0.5 joules or so like a 0.25 joules will be reflected. Of 0.25 joules, which is incident of 95% will be absorbed. Remaining some 5% of that will be reflected back. So like this. So what will happen to this? Will undergo And finally, after multiple reflections, what will happen to that particular radiation? Will be absorbed completely. So this is the radiation. Incident radiation. Now, who is a black body here? Anybody wants to answer? Small hole. Who is a black body? Lamb black is a black body. Who is a perfect black body? Anybody wants to answer? Huh? Who is a perfect black body? The small hole is a perfect black body. Yeah? So what is the definition? It should absorb all the radiation incident on it. The hole has absorbed completely and it has not reflected back. Nothing is there. The lamb black is a black body, not a perfect black body. So how to construct a perfect black body? This is a method. So this thin iron shell is not a perfect black body. The lamb black is not a perfect black body. The small hole is a perfect black body because what all radiation is in it, it has absorbed completely. It has not returned back. So here in the diagram, the small hole is a perfect black body. Lamb black is how much? 95% of radiation it absorbs. 90% of incident radiation absorbs, I'll write it. Absorbs 95% of incident radiation and 5% will reflect. So it cannot be a perfect black body. So the small hole is perfect black body. Not that iron shell. Iron shell, again, it's nothing to do. Just only to support lamb black is what? I just took that iron shell. Okay, fine. So like this, what happened? The how to construct a perfect black body? This is the thing. Okay, now charcoal. All of you charcoal. Even now, I think iron box. We do use charcoal. No. Okay. Did you ever thought why we use charcoal? The traditional iron box. I'm talking about the traditional iron box. Why do we use charcoal there? Ever thought? We don't think all such things, huh? Because we will think about movies, all that one, but such a basic observations, we are not bothered. See, very strange. Everyone wants to become engineer and nobody wants to make observation. How it is possible? How you defeat the Western science with this attitude? We have to fight, no? Okay, this I think some not looking like iron box. Okay, yeah, we'll manage. So yeah, I think so, somehow the structure will be like this, a 3D diagram. I know where to put it. So inside what happened, we'll go for charcoal, no? And the charcoal what happened will be red dot. These are the charcoal pieces. Okay. Okay. Now there'll be red dot. Am I right? Why charcoal? Why not gold? Why not we use golden pieces in that? As our gold very costly. Okay, iron pieces. Why not iron pieces? Why only the charcoal? Anybody? What is this bottom made up of? Brass, no? Brass layer. So these are the charcoals. Hot charcoal and this is a handle. Am I right? This is a thing. Okay, no. There's a traditional iron box. which is used in ancient India. So even till date, this is what widely preferred. Okay, anybody, why charcoal pieces? Hot charcoal pieces. It's a hot body. Yeah? It is 95% or around 94% or put 90% of perfect black body. It's not perfect black body. It is 95%. If a 100 joules is incident, it will absorb 90 joules of energy. Only 10% will reflect. And good absorbers are good emitters. So what I do, I'll just sprinkle some kerosene. Then I'll let it. They'll start burning. Then you compare the iron pieces and charcoal pieces. No, good absorbers are good emitters. Means the perfect black body will have more emission than ordinary bodies. So therefore, this will emit more heat. And how do I get charcoal? Very simple. Just burn wood. So if you just burn wood, what happen? The leftover is what? The charcoal pieces. Those charcoal pieces, what happen? I'll put it here. I will put kerosene, little bit kerosene, I'll sprinkle, I'll burn it. Then it start emitting more radiation. And that radiation will be absorbed by the brass layer and it will be passed. And with that, we can press the close. This was the traditional ironing method. And what is other charcoal? I'll make it powder. When I was a child, paste what happened came later. I know it. So in my house, what will happen? Charcoal with wood only we used to prepare food earlier, not now. Okay, that one, what all the charcoal pieces were, we used to make it powder, then add some salt to it. Okay, then that was the powder. What happened? I used to do that one. Later, I think in 1989, the paste, other things came. That to not paste, first the powder. Colgate powder came. Then gradually what will happen? The paste, everything it came. Charcoal is a very good cleaning agent. Salt, okay, like a antifungus, antibacterial. Charcoal is also antifungus, antibacterial, antiviral, that one. So that was the thing. I think okay, let's not talk much here. Okay, maybe we have changed ourselves. This one. So there's a thing. Now they get advertisement. No, it is having a charcoal, it is having a salt. The tooth powder was made up of charcoal and salt earlier. This was the thing. So why charcoal is only used? Because of this one. So if you go back to some Tamil Nadu, one temple is there. There, what happened? They have iron box. That iron box, what happened? Past 5,000 years, they're maintaining it. That is used only to press the cloth of God, where the God used to wear, no, the deities, to press that iron, to press that particular cloth. What happened? The iron box is kept. It is around some 6,000 years old. Just go back, no, long back, people in this land, they know how to use science. They, don't say that, sir, we only gave this radiation chapter. No, we hardly bothered to express anything formula. We know how to use science. That's all. That much I can say. Our ancestors are very good in science. They know how to use science in day-to-day life. They didn't express it, but they know how to use. That much I can say.